Hey, yo, what's going on, my guys? What's up, my guys? Good evening, afternoon, whatever the heck in time it is where you are. What's up? What is up? How's everyone doing this evening, this afternoon, this morning, whatever time it is where you guys are? Hope you're good. So yeah, just wait for the stream to pick up a little bit. We're going to be looking at some old Rockford stuff. Probably continuing on with the EPS, whatever the heck they're called, the processors that we looked at the other day. Proper headache things. This one right here is a 200IX. A proper old Rockford thing. This is a proper janky one that we're looking at just now. So I'll just let the stream pick up a little bit. I'll probably start really chatting to you guys and really talking about what I'm doing in about 5 minutes. I'm just going to keep poking around with this just for a second. And come back and I'll explain what we're doing in a minute. Just wait for the stream to pick up a little bit. Pop some of these back in place for a sec. See what we're saying. Okay, let's go drop this one in place. Actually, you know what? I'm gonna hot gun it. Actually, I'm gonna hot air gun it. You know, why not? I'll be careful. About you, but my scope cam is looking kind of sharp today, not gonna lie. What do you reckon? It's actually looking alright today. It's a little bit twisty though, you know. How do I transform this a little bit around, rotate, transform, edit transform, position rotation, let's rotate a bit around. It's a little bit twisted, hey. That's a bit better. It's a bit more straight, isn't it? Yeah. Grab the hot air gun for a sec, for a cheeky moment. Alright. So, what are we saying? Please don't give me that DC, bro. Oh my gosh. Angry Bevids. Right. I'll explain what's going on in a minute, but a little bit confused on this one, not gonna lie. So what are we saying? We've got a bit of voltage on that one though still. But how? -5. Where's that even coming from there? -5. Where's that trace going? There maybe? -5. See, nah, see, this is just feedback. Right. Right, let's have a quick peek. Right, 34 views, we've got enough people. What's going on, guys? What's going on? Evening stream tonight. Been doing a lot of daytime streams recently, but I thought I'd bring you an evening stream here from the UK. So today I've been looking at a few bits, but predominantly this freaking bitchin' ass 200IX. This is a Rockford Fosgate, an old amplifier from the very deep past, and this one was actually used previously as a parts board, as a donor board. So some ancient technician from the deep past used this board to supply parts to other Rockford amplifiers that he was repairing. I have been tasked with the task, I guess, of rebuilding this so that it functions. I would say I'm 90% there. This had a lot of issues. I've rebuilt a lot of it already, but one last kind of issue remains, really. The issue that I've got is that there is some DC in the preamp circuit I can't seem to find the source of or get rid of. The thing that's driving me up the freaking wall is that the DC only seems to be present when the op amps are installed, which would give me the impression that the op amps are faulty. However, I've replaced the op amps with about seven times, and it's not. The op amps are fine. The DC only appears when the op amps are installed, and when they're not installed, it's not present. So guys, I would love if any of you guys, because I don't really work on this old ass stuff, I'm not gonna lie, if anyone has experience working on these, I'd love for you to chime in. So Aaron, yeah, well, this one's definitely not going to be cheap, put it that way. It's been a pain in the arse. Yeah. So what I'll do, guys, I'll show you what it's doing. So basically, we've rebuilt the whole amplifier. All parts are present as far as I am aware. Fortunately, I do actually have a 600IX, I think, or is it a 100IX? I've got another very similar one of these amps that I can use as a reference, okay? Let me just see if I can grab it real quick. If I can remember exactly which one it is. What's this? This is a 100X2, not that. This is a 60IX. Here we go. Yeah, that should be the one that I can use as reference. All right, here we go. So this is the same circuit layout, I believe. Just take this out for a minute. Take a quick look at the 60IX. Get some reference. Okay. Alright, so here we have a 60IX. This is a smaller version, the same circuit, exactly the same board, everything as this one. This one's the slightly bigger the bigger version, 200IX. This is a 60IX. So I have a reference here, which is cool. I also have a fully functioning crossover card. This one's missing the crossover card. So the things that this one's missing, this is the donor board that I'm rebuilding to function. It's missing the crossover card. It's also missing the, the bass and treble knobs. But that's okay because we can bypass those. We're not interested in those. I can just set them to 0, like as if the potentiometers were in 0 position, and jump the pins that they would otherwise be connected to. So that's no problemo, my friend. We don't need the crossover card either because we can just bypass it the same as if we had the crossover card in the full range position. So that's not an issue. That's not an issue at all. The problem I've got is that you see we've got 3 op amps here. We zoom in, take a quick look. We've got 3 op amps. These were originally a pair of LM833s. So you've got a pair of LM833s here and a TL072C here. Now, for some reason, I'm getting DC on the audio path. So if I probe pin 7 of one of these, which is originally the LM833, we get a big swing to like 12 volts, which is a little under the positive VCC supply for this op amp. So, okay, no worries. In that case, let's remove the op amp and see if the DC goes away. So we remove the op amp. There's not very much thermal mass on these, so they remove quite quickly, which is nice. So we remove the op amp. Check for DC on pin 7. No DC, excellent. No DC anywhere else at all. Like literally nothing. It's completely dead other than the supply voltage pins. Okay, so you would think, great, just drop a brand new op amp in there. But that doesn't work. Nope. Dropping a new op amp in there gives us the same problem with DC. So the DC only appears when the op amp is installed. As soon as you remove the op amp, the DC goes away. So yeah, it's a very confusing situation, not gonna lie. Don't really know where to start with this. I think it might be something to do with like the feedback circuit on this or something, but one thing I just want to have a quick look at is the feedback resistors here. So I had to replace 2 resistors on this board over by the terminals, these 2 here, and I think I read them as 150, so I'm just going to double check that I got that right. Brown, green, brown, gold, yep, this is the board that I've got for reference that works fine. Just going to give that a quick measure on the multimeter here. Actually, you know what, the multimeter cam should be working today. Why is that not working? I do have it plugged in. Oh, activate, I had it deactivated, let's see. Yep, there we go. We are sideways. Okay, let's just raise that up a little bit. Just trying to get the multimeter camera all lined up, because it is very fiddly, this one, to get lined up correctly. Let's just expand that out a touch. There we go, and there we go. Okay, excelente. Yeah, so the resistance of these end ones I replaced earlier is, if I put it on the correct setting, yeah, 150. So yeah, we have the correct resistance on these. That's great. So it's a bit of a strange one, not gonna lie, a bit of a weird one. We don't have any shorted pins. All these pins are separate from one another on the op amp's position. So yeah, it's a weird one. What I'm gonna do is I'm gonna put one of the op amps in. So obviously we've got an op amp over this side for left, an op amp over this side for right, left and right channels. So what I'm gonna do is I'm gonna load up an op amp into the I'm going to call this the white hand side. This is the white RCA input. So I'm going to load an op amp up into that side, because I've been just checking the red side so far where we've had the issue. So I'm going to check the white side. I'm going to grab one of the original LM833s that was in this board, because I imagine that they are absolutely fine, and I suspect that there's an issue elsewhere on the board. Now, op amps can be very delicate with heat, so I'm being very careful here to not heat the chip and just kind of heat the legs enough that it solders down in place. There we go. Luckily there's not much thermal mass on this board, so they solder in pretty quickly. Yes, so basically the potentiometers and the card are bypassed. They are currently bypassed, the issue remains. So what I was going to actually try is to try unbypassing them, just to see whether unbypassing them gives me a bit more, allows me to find the root of the issue a bit quicker. Okay, so let's try with just this side now. Okay, so we got negative, right, so with this op amp in place we get negative DC on pin 7. It's only pin 7. Yeah, pin 7 is the issue, and pin 7 is probably going to be the output to the to this card or whatever it is. So we only get DC on pin 7. okay? But regardless of what op amp I put in place, we get the DC presence. This is one of the original LM833s. Let's drop in a brand new 072. Let's just remove this real quick again. Right, so guys, any guys that just checked, so the op amp is removed now. The DC has disappeared, okay? Op amp removed, no DC on pin 7. The DC is only present when the op amp is installed. So that would tell me that the op amp is bad, but it's not, because I've tried like 7 new ones. So let's grab a brand new 072C. Okay, you love to see it. No pun intended. Brand new 072C. A little bit of isopropyl just to cool it down quicker. But there's not much thermal mass on these boards. Pro pin 7 with the op amp installed. And we have a different type of DC this time. So before, with the LM833, we had a swing to negative VCC. However, with the 072C, we have a slow rise to positive VCC. Why is that different with the 072 versus the LM833? Let's try a 4052C instead. I didn't use a resistor to bypass the potentiometers. I literally just jumped over the pads which would have been shorted together when the resistors were turned to their minimum positions. So potentiometers are boosting the treble and bass from 0 to plus, I think it's plus 18 dB or something, or plus 12 dB. So basically, if you want flat response with no boost, you want the potentiometers in the minimum position, which shorts a couple of the pins, obviously, because the wiper is right down by one of the inputs. So this is a 4052C op amp this time. So what does this do? Does this go to negative or does it swing to positive? This one swings to positive as well, just like the 072. So I have a weird situation where I have DC present in the board where it shouldn't be. It only appears when I install the op amp, and when the op amp is removed, there's no DC. But the op amps are not dead. So it's a very strange scenario that I don't really know how to approach. Like, I don't know how to approach it, because the thing that it's pointing to is, it's pointing to, oh hey, the op amp's the issue here, because clearly it's only a problem when the op amp's installed, but the op amps aren't actually the issue. Something is changing in the circuit when the op amps are installed. Right, I'm just going to remove my jumpers that I installed for the bass and treble potentiometers, okay? And I'm also going to remove the jumper that I installed for the, what do you call it? The crossover card. Okay, right, so let's put these little bits of wire down to one side for a sec, because I'll reuse those if we ever sort this out. So just the right sizes and all that. Hey, no, don't you do that. Ah! Waste man. Okay, so now nothing is bypassed. We no longer have any bypassing going on at all. Okay, so Just want to see what's going on with this now. I still have one op amp installed here. Just want to see if there's any DC on this op amp now. Yep, DC is still present. So that didn't change anything. Alright, let's grab our known working board. This is a 60IX. So we're currently working on a 200IX. This is a working 60IX, which is the exact same circuit architecture. So what I'm going to do is I'm going to drop in the known working crossover card for this. Okay, drop that in. So we now have a known working crossover card. The only thing we're missing is we're missing these resistors. Now obviously these are for bass and treble. So with these at minimum position, we have a short across these two to start with, obviously. Then we have a short across these two here and these two here, because we're at the minimum position of the potentiometer. Same there, but these two are not shorted on this end. Okay, so me putting my jumpers in place for the potentiometer shouldn't change anything or do anything. So let's put those back in, because that's the same as having the potentiometers in place. Oh, that's true. My guy here says part of the potentiometer goes high resistance, part of it goes low resistance. That is true, actually. So what is the resistance? If we look at the 60IX here, okay, that's actually maybe not a bad shout. We've got the, so if we look at the potentiometers on the 60IX, okay, we've got this potentiometer down here, okay, which when in its minimum position, we have these two which are actually shorted on the board. There's a trace that shorts them together, okay. Then we have these two with like about a 2 ohm resistance, and these two like a 2 ohm resistance. But on this top one, we have these two shorted, but these two are not. Now, okay, maybe that's a fair shout. Maybe I should check what the resistance is between these two. It's probably going to be pretty high. Let's have a look. Okay, we have 1 mega ohm, bruv. Are you serious right now? 1 mega ohm ting. That's massive. That's a big ass resistance, right? So if I now adjust this potentiometer, that should get lower, right? Oh no, it doesn't. Wait, what the fuck? So if I put this potentiometer at, no, it's still a mega ohm. Okay, so that's not part of the potentiometer. You see? Okay, so you see this potentiometer. These two top pins here, they're not part of the potentiometer, although they do have traces going to them, so they must be, the potentiometer must be doing something for it, you know what I'm saying? So we have mega ohm between there, but that's not the actual potentiometer doing that. Right, so that's shorted. That's with the potentiometer in the minimum position. If we open it all the way up and go back to diode mode here, yeah, so we open it all the way up. Okay. I see. So, okay. It seems that maybe we can't just bypass this one. So this bottom potentiometer we can absolutely bypass, I think, possibly. Although maybe even not. Yeah, you know what, guys? It could just be that I hadn't really thought through the bypassing of the potentiometer correctly. Because this top one we have all of these pins pretty much go somewhere on the board. So naturally, if the potentiometer is not there, then it's not going to be, you know, sending the things to the places that they need to go. Okay. Right. So, in that case, now we don't have replacement potentiometers for these. Like, they seem like completely impossible to get unless someone's got a link. So, in that case, I probably just need to like figure out the resistances between all of the wipers here. Okay, so let's have the potentiometer on minimum position because we don't want to be adding any boost to the circuit that we're bypassing this on. So that's in the minimum position. So we do have these shorted. That is correct. So I'm going to put the short back. However, what about these guys? So these two, I want to check what the resistances are between all of these. So we know that these two potentiometers, these two pins here are not connected to each other through the potentiometer in any way because their resistance doesn't change as we move the potentiometer. So let's go to check the rest of them here. Go to 200k for a minute. So we know that's a mega ohm. So the resistance between this one and this one is about 1.2 mega ohm. If I adjust the resistor, does that change? No. So I'm a little bit maybe. No, it doesn't really change. What I'm looking for is I'm looking for values that change when I adjust the potentiometer. So we've got 1.2 again. No, it doesn't really change a touch, but I don't think that's actually related. Aha, here we go. So now we're getting somewhere. So these two here, with the potentiometer in its minimum position, we have 5.1k. Okay, now if we open up the potentiometer, okay, we still have 5.1k. So maybe that is the resistance between the two ends of the, not the wiper, but the actual resistive element in the resistor, yeah? So the resistance between these two is going to be the actual resistance of the kind of material inside. Okay, what about this one over here? We've got 5.18 as well, because obviously they're connected together, right? So we need roughly a 5k resistance between this top one and these two here. Alright, cool. What are we saying about these one then? So we got this one here. We have about a 5.2 again between this one and these two. Okay, cool. I see what needs to be done here. Is that the same for this one? So we have, obviously, potentiometer is at its minimum position, so we have shorts between these ones and these ones. So, do we have... this is a different value resistor, actually, a potentiometer, so we might have a higher value here going on. Might be like 500k or something like that. Let's have a look. Okay, so we've got 500k between these and these. Okay, I see what needs to be done. 500k on the bottom, 5k on the top. Excelente. Scheme. So let's do that then. Right, so let's put my jumpers back in place for the bottom and middle pins, because they need to be jumped either way, regardless of what else we're doing. And then I need to find some bloody high value resistors somewhere. I don't keep resistors in stock that are that high value. But we'll see what we got. See if I can find something on the donor board. We need a 5k or a 5.2 ideally. Something similar to 5.2. I actually lost my silicone tip for my sucker here, so I'm using it without. It's doing alright so far. The problem is it like slides around, it's slippery, so I have to hold it in place really well. Okay, let's get these little jumpers back in place. Oh, you know what I really need, guys? I know this is a custom amplifier, but I haven't really had a drink in a while. I really fancy like a nice stiff drink, you know what I'm saying? I don't really drink much these days, but I'm kind of just really feeling it right now. You're reading, Eclipse says you're reading the onboard circuits. I don't think so. I'll tell you why. Because the values that I just read on my multimeter are the actual values printed on the back of the potentiometers. So we have one potentiometer that is, I think, a 5K, and one that's a 500K. All right. So what I was doing there is I was checking to see which of these pins the resistive material in the potentiometer is connected between. Okay, which I've found out now. I've discovered. So that's cool. So if I was reading just now some random resistance like, I don't know, 6.38 like K or something like that, that's not a normal resistor value. That's not a value that I'd be expecting to see from any of the components in the potentiometer. So then if I saw that, then I would assume to myself, okay, I'm reading some resistances from elsewhere in the circuit. However, the values that I saw are ones that I would expect to see if I was reading the resistive material in the potentiometer. So you can't just take the values that you read on, if you're reading with components in circuit, you have to go in with an idea of what you're expecting to see. That way you can decide for yourself whether the value you read is roughly correct for the components that you're reading, or whether it's way out and completely different, in which case you can then conclude that the resistances you're seeing are as a result of other parts of the circuit that are getting read accidentally by being in circuit. Trust me on this one, bro. This is a Class AB, I believe. Yeah, it's Class AB. Class AB. Alright, cool. So we have our jumpers back in place. So now what I need to find is, I need to find two 5K resistors for this top one and two 500K resistors for this bottom one. Now I do not know the resistor color markings off the top of my head because I did not go to electronics school for this. So let's have a look on the internet. 4-band resistor color code. And I'll also do a 5-band as well because I've got some donor boards that have 5-band resistors on them. So we're just going to get a rough idea of what kind of colors we're looking for. I can't remember what color 5 is. What color is 5? I know you got purple and yellows 4 and 7. 5. What color is 5? Is it green? Yeah, it might be green, because 150 had a green in it. Yeah, it's green. Okay, so 5 black, and then the multiplier being times, no, it'd be times 100. It'd be red, I guess, because we already have a 0 there. Okay, yeah, so we need green, black, red. Okay, that's one of the ones that we need. But then we also need a green, black for 500K. We need, is it a yellow? Yeah, so we need green, black, red or yellow. Ketchup or mustard. There's a SpongeBob clip, isn't it? Does it say ketchup or mustard, or is it like ketchup or mustard or mayo or something like that? It's when SpongeBob and Patrick pull up, I think they pull up in the burger car to the gas station, and the guy's like, "What'll it be, fellas? Ketchup or mustard?" And there's a YouTube video where they loop that clip in like about 50 different languages, and you can see how it's voice acted in all the different languages. It's absolutely hilarious. I spent far too long watching that. Alright. So yes, I need some resistors then that are... Actually, I could probably get away with surface mount. Let's have a see if I've got any surface mounts, because that is a pretty small gap there that I could just bridge, although some of them are going to be quite big. So now maybe I'll go through hole. Through hole it's going to be... Where's my donor board, y'all? I think I'm going to have to go for a trip up in the loft and look for some resistors. BRB in loft, there we go. BRB in loft. Let's go and find some resistors, guys. Let's have a look. Alright, where's my torch? So I can see what I'm doing in the loft. Where's my torch? the old boom or bust here. You know, actually guys, I was thinking about doing a boom or bust live, just for jokes one time. Just like not a real episode, just like maybe like the sealed box. Maybe just do a basic sealed box in boom or bust, but make it be like boom or bust live. So live stream it instead, rather than it being like a normal episode. I thought it could be quite fun. But right now, I've got to find myself my torch so I can go in the loft. Here it is. Hey, my torch. Right, let's have a look. Right, so I needed green and black, and it was red and yellow, isn't it? So, green and black. What are we saying? I feel like that might be kind of hard to find, you know. Oh wait, I got... Nah, that's green and brown though, still. What's brown? Is that 2? I just thought though, there's one here that's green brown. That might be 5.2, which might work because I think I did actually read 5.2k, didn't I, on the resistor here. So let's have a quick look. Green brown. What would green brown be? 510 or... Oh, okay. 5.1. That would probably work. That would probably be fine. Green brown. And then, but yeah, what's the colour there though? That looks like it might be brown. That might be a 500 ohm. As opposed to what I actually need. Yeah, now see that's far too low. Okay. Man, look at this boy. What's he doing over there? This is just a donor board from upstairs in the loft. Okay, cool, so that's not any good. Are there any other greens on here? Shout me if you see a green. If you see a resistor that begins with a green. Not that you're probably going to be able to see through the stream, but just in case you do. Ah, here we go. Green, brown. Ah, that's green, brown, orange. What's green, brown, orange? Green, brown, orange. Let's just turn the multimeter up a little bit here. Green, brown, orange. Oh shit, where's it gone? There it is. That is probably going to be 52. That's just the multiplier that I don't need. Yeah, that's going to be like 52. No, sorry, 50. Yeah, 50k. Damn it. How about this one? 50 again. I need 5 or 500. How about this one? Nope. Okay, back in the loft I go then. This board doesn't have any 5s or 500s. I understand that you have a lot of experience with this, my friend, but trust me when I say, if I took these potentiometers out of the board, oh, well, actually we can do that because we have a board here with them removed. Okay, so this is the board with the potentiometers out, right? So if we were reading parts of the circuit elsewhere that were influencing the reading on the multimeter from the potentiometer, let's start with this top one. So we were reading 5k between this one and this one here, okay, and we were reading 5k between this one and this one here. Check the multimeter right now. Have the multimeter set to 200k, all right? So the resistance between here and here, which I was reading as 5k on the donor board, sorry, on the good board, with the potentiometer in place, we have nothing at all. We have over 200k. If I switch it to 2 mega ohms, we have greater than 2 mega ohms. So this one does have a little something on it. This one has, let's go, this one has 7, oh, it's just jumped up. This one has 1.5 5 mega ohms between it. So a little bit of board resistance there, but it's so high that it's not really going to change the fact that it is 5 kilo ohms between here and here. Reading it, it's going to be still going to be reading 5 kilo ohms down at that level. So let's try this bottom one here as well. Now bear in mind this board could still have faults on it, so we might even be getting resistances that are not supposed to be there. On this one we had 500, okay, so we're looking for 500k between here and here. Oh, this is a capacitor because we're shifting, so if I flip the probes, yeah, that's a capacitor. Okay, so we have no resistance between there at all, so the 500k is legitimate on that one, and between this one and this one, again, we have absolutely no, we're on 2 mega ohms right now, so we have absolutely no resistance there either. So the resistances that I read on the good board with in circuit, with everything correct, are accurate, my friend. That's cool, appreciate the input, but yeah, those were the resistances that I was expecting to see, and they're the ones I saw, so I knew that that was what I needed to inject into our board here. So let's go and put this Hyphonics back in the loft and find something with the resistors that we need. Okay, we've got a couple of boards here that look promising. This first board here has like a monstrous number of resistors all over it. These are 5-band resistors, so I just need to double check what it would be in a 5-band. 5-band here, it's going to be similar. I think that 5.1 is like the standard value. I don't think 5k resistors are such a thing. I think if 5.1 is like the kind of standard value. I don't know, let's go black. So yeah, it's so we're going to have the same sorts of colours here, green, brown, but we want, no, hang on a minute, we want green, brown, black, brown, gold is one of the ones we need, and orange. So if we're looking at 5-band resistors, we need this middle band to either be, this multiplier band to either be brown or orange, with the green at the start. Okay. These are quite hard to see, but let's have a look. That one there might work. I need a loft cam. I did actually just consider that. I thought I might need a loft cam. Alright, what have we got here then? What are we saying? Okay, well that's a very low resistance there. That's now in this one we could be reading elsewhere on the board. I absolutely agree. It looks like it has a green at the start, but then it has like brown, brown, gold perhaps. The colours on these resistors from this board are very hard to make out. The yellows kind of look greeny and they're all a little bit hard to see. There's definitely a green at the end there, but I think that's mega low resistance, that is. So sort my snake cam out. Okay. Alright, let's try the other donor board that I brought down. Now this one definitely has a resistor on it that looks good. It's right over by the output transistors. Over here we have a green, brown, red, gold. Now that's the 4-band. So that is going to be, if my memory serves me right, the 5.1. Is that going to be the 5.1? It says 4.82, but we're in circuit, so yeah, might have been a little bit of circuit resistance. So I'm going to grab that one out. It's a big chunky resistor. It's pretty big in size, but it's the correct resistance, so we don't really mind too much. So let's grab that one out. That's 1, 2, 3, 4 from the edge there. Okay, so let's have a just check of this resistor out of circuit. Make sure that we have the correct resistance that we need. Drop it into the tester, why not, might as well. Okay, yeah, pretty much 5.1k, excellent. There's one of our 5.1s. Now we just need enough fun of one more of those and then 2 500s. So the 5.1s were up on this top resistor as far as I remember, and we need 2 of those. We need one from here, and it was this top one was connected through to 5.1 to these bottom 2 down here. So let's just quickly shove that on there, go through the loop that I've created with my little jumper wire and get that in there. Made a nice convenient little loop there for the wire to go through. Provided I haven't filled it with solder, which I don't think I have, but maybe I have. There we go, you love to see it. That looks wicked. Alright, awesome. Let's do that, shove that in there, get a bit of solder on that one before it falls out. Yeah boy. Okay, cool. So that's going in this top one here. Muy bien. Okay, next up is going to be the 5.1 between these two, or a 500 between these ones down here. So let's see what else we got on this donor board right here. Looking for another 5.1 or a 500. Saeed Danak says, well, you have a hot module. Man, what can I say? Thank you very much, buddy. I'm sure you do as well. Green. Where's my green guys at? Oh, is that green in there? Ooh, is that green black? That's a five. That's the 500. Don't want that. All right. Continue. Ah, here we go. What's this? This looks like it has an orange on the end, so that's going to be a 500 possibly. Green, black, orange. We're reading 200 on the meter, but as my guy here, 1998 Eclipse, has very well said, reading resistors in circuit is a no-no because you're reading elsewhere on the circuit as well. So let's get this out. This looks like a green, blue, orange, which might be close enough. Provided we're the same on both parts of this resistor, we should be okay. Can't remember what blue is. What's blue? Blue, blue, blue. Is that a 3? Green, blue. So that is the third one from the right, which is that one there. Helps if I turn my soldering iron on. 1, 2, 3. My guy 1998 Eclipse is foreshadowing that this isn't the way that the potentiometer works and you're going to cause yourself more issues. Very possibly, however, these potentiometers are no longer available to buy, so we're trying a bypass. I have bypassed potentiometers before in preamplifier circuits with good success doing this method, so I think that we're going to possibly have a reasonable chance of success, given that the way that these potentiometers are working is that we have basically they're like a 0 resistance when they're in the minimum position, so that's pretty easy, and then we just need to connect the rest of the resistances up to the correct places. Ah, we got a 57k. That's not what we want. No good at all. We need a 500. Wait, what was that? Why was that 57k? That was an orange. I'm pretty sure the orange is the one that we needed for the 500. No, 4 band. 51. Oh, okay. No, we need yellow. Yellow is the one we need. Orange was for a 5 band. Okay, so we need yellow, not orange. Nah, most of the green resistors on here are followed by orange. So, okay. Well, we got one resistor off this board, didn't we? We got one of the 5.1Ks, which is cool. It's interesting though how this board only had like is this a mono amp or no? It's a 2-channel amplifier. So there should be there's another 5.1K over this side. Excellent. I was going to say this is a 2-channel amplifier, so you got 2 identical like channels on here. So we should have more than one at least, which we do. We've got another 5.1K over this side, so I'm going to remove that one. That is going to be 1, 2, 3 from the left. Flip her over. 1, 2, 3 from the left. That's this one. 1, 2, 3 from the top. Yo, Mark Jackie, 10 euros. Some solder money, my boy. Yo, thank you very much, Mark. That's really kind of you, bro. Trust me, solder does not last long around here, I'll tell you that. Thank you very much, very kind of you, buddy. Hope you're doing well, Mark. Hope the amps aren't giving you too much hassle, because I know that you are a soldery boy as well. Okay, let's get this in, see what we're saying. Great stuff, there we go. Love to see it. You love to see it. Okay, so now we need a couple of 500s for the bottom down here. I'm good, thank you, Sid Nedges. Thank you, buddy. I'm alright. Not too bad. Palm Trees, long time viewer, Sam. Love the streams, appreciate the knowledge. I don't really have a great deal of knowledge, buddy. I'm just very jammy when it comes to problem solving and stuff. I just somehow managed to get things working again, somehow. Yeah. But I appreciate the kind words. Appreciation from Australia. Nice, man. Hope it's good out there. Hope you're not too hot. In English would be Sydney. Oh, yes. Sydney. Because J and S absolutely make an E sound. No, I'm joking. That's cool. How do you say it, like phonetically, in your language, buddy? Is it still Sydney? Does the EJS make an E sound? Right, back in the loft for me then. Back in the loft then, looking for 500Ks. BRB, guys. Behave yourselves. JBL. man, you know what? Finding resistors with the yellow multiplier seems really hard. There's not a lot of parts of various circuits that use like resistors in the kind of 500k range. So I've got this board here which has a bunch of different resistors on it. It seems, is it me or is it dark in here now? I've just been looking at the light too much. So this one has a bunch of resistors in it, and I did see some that were in the right kind of ballpark, but none that were really the right kind of value. Got a bunch of 100Ks. Got brown, green, yellow. What's that? Brown, green, yellow. That is 150k. It's way too small. Like, we need a bunch of those in series if we're going to get anywhere near the 500k that we need. Right, what about 1 mega ohm? Maybe I could just do a pair of 1 megas in parallel. Maybe they'd be easier to find. So 1, 0 mega. I guess that would be green. So that would require a green multiplier. Brown, black, green, gold. Do we have any on this board, for example, with a green multiplier? Oh wait, what's this? There we go. There's a 1 mega there. So there is a 1 mega. So I would need 4 of those because we need to parallel 2 together to give us the 500 that we need. So I've got 2 of these donor boards. So I've definitely got 2 of them, but I need 4. So I need to find another location that has a 1 mega in it. Will I be able to find one? Don't think so. Heck, man. Alright, what about this other board? This board right here, this is a JBL GTO 1200. Really nice amp. Shame that it's ended up as a donor, to be honest, but that's what it is. Wasn't my doing. It came as a bunch of donor boards and it was already like ripped to shreds, so couldn't really save it, and I had no heatsink either. So okay, looking for, here we go. Looks like we might have a few mega ohm resistors on this board. Got brown, black, green, gold. There's one there that I found very quickly, so chances are there might be a couple more on here as well. Fingers crossed, finds a couple more. Okay, maybe not. Right, I'm going to start by taking that one out that I've seen, because that's definitely a 1 mega. Okay, that's the second one up from the bottom here. So, do you do box designs by any chance? No, I don't. Well, I do box designs for myself, but I don't offer them as a service or really do box designs for anyone else, really. I don't really consider myself good enough to offer my box designs as a service. Wait, I'm not in the loft anymore. There are definitely people that offer box design as a paid service and that take money for box designs who aren't maybe as experienced as I am with box design, but I just don't feel like I want to make that be a service. I don't feel like, you know, I'm really good enough to be charging a service for that. Even though people with the same or less knowledge than me do, I don't think that I want to. So the way that I work is I only ever want to charge for a service that I truly believe in myself in, and I know that I can deliver, like what the client wants or needs. So I know for sure that I can repair an amplifier for somebody, right? Pretty much almost every time. There's very, very, very few and far between times that I can't fix something. So I'm happy to offer that as a service. But yeah, box designs, I'm not confident in myself enough with box designs. Like, oh yeah, I could design some boxes and they'd be loud enough, but I'm such a perfectionist. If I was designing a box for someone, I'd want to be on Hexibase's level. If I was at Hexibase level, yeah, sure, of course, I would offer my box design services. But I feel like I'm not at Hexibase level yet, and probably won't be, because that's not anything I'm pursuing really with great detail. So yeah, I probably won't be offering that as a service. Right, that's one 1 mega ohm resistor removed. I just really want there to be a couple more on here, just so I can have 4 in total for my shears. Can't really see any more on here, to be honest. Alright, what about on that other board that we had? Right, so yeah, we weren't looking for 1 mega ohm resistors, I don't think, yet when we were looking at this board. So let's scan for 1 mega ohms on this one. Come on, there's got to be at least one. God damn. Oh, there we go! Woohoo! Found one. Okay, excellent. So we've got 2 now. We've got 2 1 mega ohm resistors. So I'm gonna need 1, 2, third one in. Third one in. There's that one there. So I'm gonna need 2 more. Now I know where there's a third one because I have 2 of these donor boards. So I can grab the third one from the other one of these donor boards. So now I just need to find a 4th. And then we have our 2 500k resistances that we need. There we go, so there's 2. So I've got another one of these donor boards up in the loft, which I'll go and grab the third one of the 1 megas off, and then we just need a 4th. I'm just going to double check one last time that there's not another mega ohm resistor hiding away somewhere in here. Nope, doesn't seem to be. Alright, grabbing the other one of these donors. There we go, guys. Found my final two mega ohm resistors, so we can run them in parallel, get our 500 that we need. Finally, right, so this one is the same one that we removed in the same location as the other board, this one right over here, so let's grab that one. Third one in from the side. 1, 2, 3, that's there. Awesome stuff, that's that one. And the last one is on this other donor board that I've got, which is here, and that was over by the power supply, which is R17, which is 1, 2, 3 from the bottom here. There we go, we finally have our quad mega ohm resistors. So let's drop those in place down here on our board that we need to put them in. So we need to go from here to this bottom one. I'm going to drop some isopropyl alcohol in here because there's a bunch of flux that's all getting in the way. So that needs to go down there. And we need a second one. I don't think I'm going to be able to fit both leads through the same hole, but we'll try. Oh, you know what? We can. Awesome. Love to see it. There we go. Maybe I'll go around the outside so that we can do the other ones on the inside. Okay, there's our first two, so now our second two. Pretty much a whole live stream of Sam finding a couple of resistors. Absolutely, you know you love it. It's what it's all about, you see. You're joining me here in the workshop for my evening. That's what it's all about. Mugsy says, where would we get hold of you? So basically you can contact me on Facebook via the BearVids Facebook page. Just search for BearVids on Facebook, I'll come right up. And if you're in the UK, I will happily look at your amp for you. If you're not in the UK, then my man, you want to find yourself a technician in the same country as wherever you are currently residing. Alright, cool. So, maybe that's our potentiometers correctly bypassed this time. We'll see. So I'm going to drop the op amps back in place. I'm going to put the originals back in. The LM833s and the 072C that was in location. So let's do that real quick. And see how it behaves now. Okay, so that's all the original parts back in with the resistors, the potentiometers, fingers crossed, correctly bypassed this time. And let's see whether we still have strange behaviour with the preamp or not. Just going to go ahead and plug the wires back in. Power wires kind of fell out. We've been spinning this around a few times on the bench here. Okay. Alright, cool. Let's see now then whether this is going to work or whether we're still going to get random DC in our preamp stage that should not be there. So give it a little bit of power. Started with 10 volts to start with, nice and low, keep things safe on the rail voltages. Not going to give it any RCA signal just yet. I want to get it powered up and see what it's doing. We do have our crossover card from the working amplifier fitted, which we'll need to bypass this as well when it comes to it, because we are missing a crossover card entirely. This one didn't come with one. So, okay, cool. Let's power it up and just see what we've got going on these op amps now. Ah, you know what? That's actually fantastic news. We don't have our DC on our op amps anymore. Wow, okay, fantastic. So it seems that, yes, I just literally didn't have all of the pins for the potentiometers connected up when I had done a quick bypass earlier. I just don't know why, I just hadn't really thought about it properly. I thought, okay, let's turn the potentiometers on our working amp to the minimum position, which is where we want them to be bypassed at. Let's read the resistances. I read a couple of shorts between some of the wipers, the wiper and the ends, which was in the minimum position. So I thought, great, we'll short those out, as that's how it is supposed to be in minimum position. But I hadn't considered the other two pins which weren't shorted. I didn't consider that they might need to be connected elsewhere. So we've got RCA signal going in now, 297 Hertz. We're going to be checking this channel first, see what we got. 5, 2, oh lovely, yes boy! We have the sine wave, nice clean looking Rockford Fosgate sine wave on that channel. Let's jump over to this second channel right here. Let's have a look, make sure this one's functioning as well. Yo, beautiful, my mate. Yo, that's what I'm talking about. So this is a parts/donor board that the customer supplied to me and said, Sam, see if you can get this one back up and running if you can. If not, no worries. But yeah, this amplifier was used by a previous technician as a donor, as a parts board. I had to replace a million things on this board, and correct the issues that the previous technician, whoever worked on this before, that decided it was going to be a donor board now, couldn't seem to fix. So I'm just going to place all these other op amps that I was messing about with back in my drawer, because these are all fine. One thing last we need to do on this board is we need to bias it. We need to bias the channels correctly, and I'm just going to go by current draw. I'm not going to go by any other methods on this one. And also I do want to go ahead and quickly bypass the crossover card, because we're going to be running this amplifier full range, so we don't need the crossover card fitted. So this is the good board that I stole the crossover card from previously, put that back in. This is a 60IX, and this one we're working on is a 200IX. So in order to bypass the crossover card, we need to make a small wire bridge between, and don't worry, I did actually check that this is correct method by looking at the traces on the crossover cards for full range position. We need to go ahead and solder a jumper here between, let's zoom in a little bit, these two here and these two here. A bit more solder, I think. And the last ones is going to be, it was these two here and these two here from memory, I think it was. Yeah, it seems to be about right. Okay, cool. So that should be the crossover card bypassed. So just double check that we still have nice clean sine wave on the outputs, and I'm going to check the frequency response as well to make sure that it's flat and doesn't like have any kind of things like where it's not really a flat frequency response, because this is supposed to be running as a full range amplifier now without any crossovers or any bass or treble adjustments. So I'm going to re-bias each of these channels here real quick, so I can turn the biasing down to 0, power the amplifier up and idle it with no signal and we're just going to go by current draw on this one. These Rockford amps are nice and clean anyway. There's not really much crossover distortion anyway, so provided we see a slight increase in current draw, we know that there's a little bit of overlap between the FETs, the output transistors here. So power up. So we're idling at 0.6 amps with no biasing. So I'm just going to increase this bias potentiometer, and we're going to go up until we see 0.7. Maybe we'll go like we'll go to 0.8 and then we'll back off just a touch, just to the top of 0.7. So up to 0.8. I'm just going to back off a touch until we just yeah, there, 0.7. Cool. So that's that side biased. Just check for heat on these. These are all good. So now we're going to do this side, and we're going to double check that we have 20 kilohertz looking clean with no crossover distortion as well once we've done this. Now this side, so we should see a jump to 0.7, and so I'm just going to go up again this time because we're right at the top of 0.7. I'm going to go up to 0.9 and then just back off to 0.8. So there's 0.8, there's 0.9, back off the touch to 0.8. There we go. So now if I inject some RCA signal, just going to make sure that this is playing nicely full range with no attenuation to any of the frequencies that are coming through here. So now we shouldn't idle the amplifier too long. We don't have a heatsink connected. We're not biased very high. This is a very low bias. So it shouldn't really overheat too much anyway, but we're not going to leave it on too long because we can have thermal runaway of the output transistors without a heatsink when this amplifier is biased, as it is now. So we have 297 Hz going in at the moment, which is looking good. We have a sine wave that is about 5 volts RMS. So we just want to make sure that we have about 5 volt RMS sine wave. We're at 177 Hz. Let's go up and just check. Yep, still got 5 volts RMS sine wave there. Let's go up in frequency now to higher frequency. This is a very old ass amplifier, so yep, 5 volts RMS. We're up at 1000 Hz now, 1 kilohertz. We still got 5 volts RMS sine wave all the way up to 2.2 kilohertz. We're still at 5 volts RMS, so that is flat so far. Let's go up again. Let's just double check for heat on the transistors, make sure we've not got thermal runaway. No, they're nice and cold, they're nice and chilly. Okay, cool. Let's continue. We still got 5 volts RMS up to 5 kilohertz, 6 kilohertz, 5. Yeah, I got a little bit, 5.1. Yeah, it's about flat. Up to 15 kilohertz and 16, 20 kilohertz. We're still at 5 volts RMS. So yeah, this is dead flat, and we don't have any visible crossover distortion on the scope here at 20k. So we are biased. Excelente. Excelente, muy bueno, amplificador esta buena funcionaba. Algo más. Let's just check the same on the other channel, just want to make sure the other channel was good as well. So yeah, all up to 20 and all the way down. Yeah, the other channel's good as well. Excellent, we have brought back from the dead a parts donor amp. We brought it back from the dead. Right, what parts did I have to replace on this? It's a shame I didn't live stream the whole repair of this one, actually. It was pretty intense. So, to get this one back up and running, we had to do the following. Replace all... Actually, I tell you what, I'll unplug it here so I can show you what I had to do. This one was pretty bad. Like I say, it was a parts amp, so yeah, it was proper bad. It had all sorts of missing from it. So we had to replace the power supply filter caps. Was one thing. I had to resolder a remote terminal onto here. We had to replace the resistor for the LED that was missing. That was hard to find. We had to have a new rectifier over here. All new output FETs on here. We needed some new 0.1 ohm resistor, 0.1 ohm drain resistors. Not drain resistors. Yeah, I guess it would be drain resistors because these are MOSFETs. So yeah, we needed new resistor here. We needed new 150 ohm resistors over here. We needed a new capacitor in the middle here, which I think is part of the power supply circuit, some kind of filter or timing cap. What else was missing? Oh yeah, on the bottom of the PCB, we needed 2 new diodes here, which are probably going to be protecting against reverse polarity connection. I believe maybe this amplifier was actually connected in reverse polarity because these diodes were missing. We also had a blown trace on the bottom of the board that leads to those diodes, which I've replaced with a piece of wire. Also, the capacitors were missing as well, which suggests to me that they would have failed in a reverse polarity event. So I think that what happened is this amplifier got connected in reverse polarity at some point, because yeah, I had to replace all those parts. We also had to do some trace work over here. The power terminal wasn't connected to the main board anymore. It was just completely blown open, burned, so we needed to make a repair there as well. We needed to mount some gate resistors in a bit of a funky way over here to the board to get them connected to the FETs, because the traces are all missing over here, so that's kind of interesting, but it's good, it works. Trace was missing for this MOSFET here, which is now working. What else? Oh yes, output section. Obviously we needed to work out how to bypass this crossover card which was missing, and also bypass these bass and treble potentiometers which were missing, which is what we've just done with these resistors. What else? Oh yeah, some gate resistors were missing, some 10 ohm gate resistors were missing as well. Oh yeah, and power supply drive transistors were dead as well. They were dead. And we also needed all new power supply MOSFETs. Didn't mention that, they were all dead as well. So this amplifier has had a lot of work done to it. Now the repair cost that I'm going to have to charge for this is going to be more than this amp's probably worth, but it is a piece of history. This is a great amplifier from the olden days, and I'm sure that the customer will be, he loves his old stuff. He's a very nostalgic guy probably with his old Rockford stuff, so I'm sure wouldn't mind paying the price to basically get this thing rebuilt and fully functioning once again, playing some sweet tunes through it as it once did back in the day. So I'm pleased with that. That's good to go. Alright, let's put the, this is the other one, this is the other from the same series. This is the 200IX, this is the 60IX. I was using this one for reference to repair the 200, getting all the resistor values that I needed, etc. So let's put this back in its case before we lose it or anything. 1998 Eclipse, man. I don't know why you're having a bit of a tantrum over there, my friend. It's all good. I did say at the time, someone, it was probably you, someone mentioned, oh hey, you've probably got the op amps with the one of the inputs or the outputs floating, and that made me think, that's true. If it was floating and not connected to anything, then what's going to happen is the op amp is probably just going to swing high or low on one of its outputs. So then we started looking at the potentiometers, and I'm pretty sure I did actually say at the time, yeah, that's a very good point, thank you very much. But don't know if I'll be able to find that now. But you were convinced the whole time, my friend, that that wasn't going to work, and well, it worked. So what can I say? You have to remove the pots to get accurate resistance values. Well, that wasn't the case with this one, but I appreciate the advice there. So yeah, basically, I can't remember who it was, but somebody said that when the op amps are disconnected, then that can cause that to happen. Where was it? Can't remember where it was. Don't know if they said floating or not, but don't know if it was you. Yeah, I can't find where it is, but I saw a comment that said something about the potentially something about the op amp not being connected, and that made me think about that, but can't find who it was. But I'm just glad we got it working, man, and I'm glad that you were here to witness it and to join in. I appreciate all of you guys being here, so thank you very much for joining in. Put it back in there. Here's the 200IX case. Greetings from the Dominican Republic. Yo, how's it going, buddy? Thanks for jumping on. Hope you're well. Okay, fantastic stuff. Right now, gentlemen, I think I would like to move on to the processors. I had a very generous person in the previous stream that gave, actually no, hey, was it this one I want? No, there's one more Rockford amplifier that was giving me a headache that I want to look at. I think that's this one right here. Let's have a look at this one together. Before we look at the processors, I want to get all the amps out of the way. So this is a 100 DSM. This is another old school Rockford amplifier, 100 DSM. So let's plug the power wires into this one, see what she's doing. I think this one was kind of being a bit of a pain in the butt, so let's have a look and see what we got. Greetings from the Mexican border. What's up? I'm trying to escape America, mate. I think I would be too. No, I'm joking. America's alright. I've not actually been to much of America. I've only ever been to Oklahoma and Dallas, so I don't know. Would you want to be escaping Oklahoma and Dallas? Maybe, maybe not. Don't know. I had a good time when I was there, but I wouldn't want to live there. I don't think it's just it's so different to the UK. It's so different to what I know. Just giving myself some fresh power cables, because obviously they eat their way down, don't they? Let's have a look at some live chat real quick, see what you guys are saying. How's it going, guys? How's it going? This is true. Palm trees, I actually have the exact same problem. So yeah, even if a customer sends in an amplifier that's like very cheap, the repair, you know, the maximum repair cost could never be too much, because a replacement amp would be pretty cheap. Sometimes I will just spend far too long on it anyway, just because I get annoyed by the fact that it's like difficult, or something's like beating me, or like I'm having trouble with it. I'm like, no, I'm gonna fix this. And obviously I'm not able to charge for that extra time, but sometimes you just got to get it done just for your own well-being, you know. enjoy watching you work and the streams. I appreciate that. I'm glad that it's enjoyable to someone. I'm just doing my own thing here anyway, but I'm glad that it's enjoyable for some people as well. Okay, so what do we have going on with this one? 100 DSM. Let's plug in some RCA signal. And let's see what we've got on this. So, power supply on. Power up the amp. Ooh, okay, a massive swing to what looks like positive rail there. Okay, so we've got positive rail on one channel, and on the other channel we have a little bit of negative voltage here. Is it positive rail, or is it just like... It's not positive rail. Oh yeah, it is positive rail. Okay, so one channel swing to positive rail. Boop. And the other channel down at negative 9 volts. Okay. Now, I don't think... So we don't have any dead or shorted output transistors or FETs on this one, because if we did, then the DC would be there before the biasing actually activated. So what I'm going to do is I'm going to reduce the bias potentiometers to 0 on this one, just to kind of see if that affects the DC on the outputs in any way, and then we know where to maybe look at. Ah, interesting. So on this one, with rail voltage being sent to the speaker terminals, adjusting the bias potentiometer doesn't actually seem to do anything, doesn't increase the current draw from the amplifier at all. So it looks like we're either missing bias supply, or the bias supply circuit isn't working properly. How about this channel here? That's very noisy, but then when we increase the bias, we get rid of the noise a little bit. So this channel appears to... Yeah, this channel is working better. We actually have biasing working at least in some regard on this channel, because as we increase the bias potentiometer, the current draw from the amplifier increases. Although we do have some DC on the channel there, which shouldn't be there. But I'm just going to increase the bias a little bit here, just to get it just under the point where it starts drawing current. So that channel is now kind of biased, but we do have a bit of a negative DC there. And that comes in when the bias supply activates. So we have an issue with this channel. So we have driver cards on this amplifier. So if we wanted to very quickly identify whether the problem is on the driver card, or whether it is on the whether it's on the driver card or whether it's actually on the main board, is we could swap the driver cards around from each other, and that would tell us a bit more about that. I'm also interested because it could be coming from the preamp. Another thing which could be happening is this could be coming from the preamp circuit. So if the preamplifier circuit is faulty and it's sending DC to the drive circuit, there might not be a high pass filter to block DC between those two circuits. There will be a DC blocking capacitor between the RCA input and like the amplifier at some stage. But if the fault in the preamp circuit is after that DC blocking capacitor, then any DC that's injected or leaking in the preamp circuit after that will actually make its way to the drive circuit for each channel, and therefore you will get DC on the terminals. Now the fact that the thing that's making me think that that's not the case though is the fact that we have the bias potentiometer not working on the channel. That tells me that, well, the issue is unlikely to be only in the preamp circuit, because if that was the case, the biasing would still work fine. We just have DC on the output. So I think that, yeah, we definitely have what's going to either be a bias circuit fault or a drive circuit fault on at least one of these channels here. Okay. So, how do we attack this one to start with? I'm thinking maybe to start off just by swapping the driver cards around and seeing if the problem moves side, because then we know for sure that the issue is probably going to be on the driver card. What do you guys reckon? What do you guys say? What would you do in this case? Would you just like start off by swapping the driver cards over and just kind of seeing if the issue moves side? Because then you've just focused on a small area of the circuit that the issue is probably going to reside in. What else might be tempting to do as well is to remove the preamplifier card, because that will then, by removing the preamp card, we then remove any possibility that the preamplifier is causing the fault as well. One quick thing I'm going to do is, because of the amplifier we just repaired, we know that the audio signal gets routed through these bass and treble potentiometers. So there should never be any DC on these pins for the bass and treble potentiometers. So I'm just going to power the amplifier up and just see whether there's any DC on these. Because if there is, then that suggests there might be a preamplifier fault as well. A little bit of DC on one of these, maybe like -1 volt, maybe? Okay. Ah, well, hey! We got -14 volts on here, -13, and a little bit on that one. Okay, that's not good. What about over here? Okay. So there's no DC on this potentiometer's pins. However, we do have some DC on this potentiometer's pins. So these are just going to be bass and treble. Okay, so we're going to have channel 1, channel 2 input, and then outputs for the potentiometer for each channel. So we're going to have both left and right on both of these potentiometers. It's not like one's for left and one's for right, I don't think. Let's just grab the case here and have a quick peek. So yeah, if we have a quick look at this, it's going to be this way up. So this one right here is bass boost control, and this one over here is treble boost control. Yeah, treble boost control, bass boost control, and that's for both channels. So it seems that whatever the issue is, it's being injected in the preamp stage after the bass boost circuit, but before the treble boost circuit. Now, it's a bit of a weird one, because I would have said at this point, based on what I've seen, that this is going to be just a preamplifier fault. The reason for that is because this amplifier can be bridged without flicking a switch, okay, the polarity on the speaker terminals is going to be flipped opposite. So let's say, for example, the preamplifier is injecting DC to the signal before going to the drive circuit. If the DC being injected is the same on both channels, then because of the way that the polarity is going to be flipped, you would end up with negative on one channel and positive DC on the other channel, which is actually what we see. We have -10 on one channel and positive, like, rail pretty much on the other channel. And on this potentiometer here, we have -1.2, -13, -13, -1.2. So it kind of says to me that maybe we got negative voltage leaking in the preamp circuit, but by the time it gets to the output, the polarity is flipped, so that's why we've got negative DC on one side and positive DC on the other. Yeah, so interesting one. Okay, what I think to do is to start looking at, well, I think we definitely have a preamp fault, because we shouldn't get any DC on the potentiometers there unless it's part of feedback. I'm just thinking about feedback. If there's a drive circuit fault, that might be feeding back like into the preamp circuit, and then we'd end up with DC at the preamp circuit as well. Yeah, okay, the first thing I'm going to do then is I'm actually going to remove both of these drive cards, and I'm going to power the amplifier up and see whether by removing the drive cards we still have DC on the preamp, because that's an easy test. If we still have DC on the preamp with the driver cards removed, then we know we also have a preamplifier fault. But if the DC goes away with the with the driver cards removed, then we know that the DC on the preamp is just caused by some kind of feedback. Okay, that's our course of action to start with. Let's make sure that there's no rail voltages left in the board here before we start sticking our soldering iron anywhere near it. Okay, fantastic. No more DC in there. There's always a stiff drink waiting for you if you land in Australia. Man, thanks Palm Trees, appreciate that, buddy. I might take you up on that at some point. It's a long way to go though, Australia, man. The flights are heckin' expensive. What are your thoughts on Scar Audio? I mean, their amplifiers. Their amplifiers are generic circuits. However, like, I have never seen one in person. We don't have a Scar Audio distributor in the UK, so I can't speak from experience, but based on what I see on like guts pictures and stuff like that, they seem to be relatively okay, relatively well assembled. They're not the cheapest build that you could get from any of these factories, and the circuit designs are generic Korean, but they worked in the past. They're tried and tested. They're all right. I can't really speak for whether they're good value for money because obviously your currency is different to mine. I don't really know how that pans out, and whether they are actually cheap for what you get or not. I still stand by the Brazilian stuff being the best value for money when it comes to sub amps. Not necessarily for mids and highs. Mids and highs, it really matters about the actual circuit design quality and all the. Yeah, it really matters for mids and highs. But for subwoofer application, dynamic headroom, having power is really the most important factor. The actual cleanness of the Class D section is less of a factor, just because subwoofers are not really able to make those differences be transparent enough. But yeah, for subwoofer amplifiers, I still think the well-built, well-designed Brazilian stuff is going to be the best value for money. But aside from that, if you wanted to go Korean, then probably something like Scar is going to be a fair shout. Okay, so these driver cards are soldered, like they're this kind of old school style thing where you got these little solder blobby things on like a piece of PCB that's just shoved through a hole in the board. So I'm just going to use some solder wick to disconnect all of these solder blobs and get this card removed. This could prove a little tricky because we need to absolutely get rid of all of the solder and make sure there's no connection to the card left. So the solder wick should do a good job here. Yeah, it's doing an okay job, but it's the solder's still kind of tacked up at the edge there, right by the card. For anyone else that works on these regularly, what's your kind of go-to way of getting these cards out? Is it this method that I'm using here, or do you have some other nice method? I might actually be tempted to use the hot air gun. That might be good. There's not much thermal mass on these pads here, so doing the hot air gun across it and just sort of like waiting for it to fall out, or just giving it a gentle pull from the other side might actually be a quicker way of doing it. Hot air station, no question. Okay, yeah, that seems like it might be the best shout, to be honest. Because I've started by doing it this way on this one. I'm just gonna see how it goes. But if I struggle to get it out in like a minute or two, then I'm just gonna go hot air. Yeah, I think hot air is gonna be the best shout here. That still feels like absolutely stuck in there. So yeah, hot air is the way forward for this one, I think. Turn the pressure up a little bit. Are you going to Slamology this year, man? I've never been to Slamology. it's a long way to go for a base meet. It would cost a lot of money. I wouldn't go to America just for Slamology, as much as I like car audio. What hot air gun do you use? It's just some cheap AOUA thing. You can get them on like Amazon and eBay and stuff. I got it second hand when I was getting into repair because I didn't want to spend a bunch of money on repair equipment if I wasn't going to be any good at it. But yeah, it seems to work for me so far. Mike Honda, thanks for the 10, buddy. Appreciate that. Good day, Bear Vids. Just finished work, caught the stream. I'll sit back and get caught up. No, I appreciate you jumping on, man. Thank you very much for the 10 as well. I hope you're having a good day. This isn't really proving too easy either. I was hoping that it might kind of fall out at this point here. Let's give it a little wiggle. Yeah, I don't want to damage the board here. I might flood a bit more solder on here. So putting a bit more solder on here might be a good shout, because then there's a bit more solder to hold the heat in as I move the gun around. Is it temperature adjustable? Yep, it is. I can't tell you how accurate it is, but it, you know, it works for me. But I never adjust the temperature really. Like it just stays on 400 the whole time. All right, let's see if that's any easier now with a bit of solder on there to increase the mass. Okay, I think all of the solder's melted, but you know what it is? Because I'm heating up the PCB, I think it's expanded, so it's actually kind of stuck in the gap because it's expanded a bit. So I think I need to kind of put a bit more pressure on pulling it out. There we go. So yeah, it is definitely going to come out in a minute. I just need to put a bit more pressure on pulling it. No, you know what? I don't think this has even shifted once. Come on, you stupid thing. Right, let's try it with the iron instead. Let's try it with the iron and completely flood it. Let's flood it enough so we can get to both sides just from the top here. Like that. Kind of like that, I guess. Yep, there we go. And now let's give that a pull. These are definitely all melted, but it's very stuck in here. I think just because it's expanded so much from the heat. Yeah, it's very, very stuck. What I don't want to do is pull it so hard that all the solder falls through and burns my finger, like by falling through. I'm probably going to burn my finger here. Come on. Come out, you stupid thing. There we go. Okay, I got my finger out just in time, I think. Woo! We are out finally. Okay, so that is the method. Just need to pull nice and hard because, yeah, obviously it's expanded, so it's going to be thicker in the slot than it wants to be originally. Okay, let's see if we can pick up this solder blob and move it over to the other side so we're not wasting a bunch of solder. There we go. Moved it over to the other side. Love to see it. Let's do the same on this side. This side might be easier because I won't be heating it for as long as the other side probably. Okay, let's start wiggling. This is freaking tough to get out of this. This is harder than just like a regular through-hole driver card for sure. It proper gets stuck in there, doesn't it? There we go. Okay, not too bad. Right, so let's get rid of all this excess solder because we're going to power it up now without these cards fitted and see whether the DC on the preamp circuit is still present or not, and that will tell us a bit more about what's going on in the preamp. Let's just make sure we've got no solder bridges anywhere on here. And same on this side. Yeah, I think we're looking good. Looking good, looking good. Alright, fantastic stuff. So I'm just going to remind myself which one's top and bottom. So this one was the top one, and this one was the bottom one. So I'm going to put them in that order over here. Okay. So yeah, with those cards removed, let's power it up and see whether we still get DC on the preamp circuit. And see if we still get DC on the outputs as well, because if we still get DC on the outputs, we know that there's an issue on the driver card further towards the FETs here. So power, and let's see what we got. Okay, so with these driver cards removed, it would seem that the amplifier doesn't want to turn on and it's drawing excessive current, probably because there's nothing to prevent the output transistors from just like switching on. I'm just going to double check for soldered bridges one last time. I'm not seeing any bridges, so without the cards fitted, do we get any? Okay, so this side looks like it wants the output transistors to be like on fully. I'm just going to roll over with the soldering iron one more time over here, just to make sure that there's no bridges. So a little bit of fresh flux. Can't see any, but sometimes they're so small you can't actually see them with your eyes. Check the other side of the board as well. Okay, looks okay. So there's actually no drive transistors on the main board. So all of the drive transistors are on those daughter boards. And that might mean that we actually need to connect together the gate and source of these MOSFETs to prevent them from spontaneously turning on. You understand? Yeah, looks like that's what's happening. So because I don't think there's any pull down resistors or anything on the main board here by these FETs, it's the same as with the Class D. If you remove the drive circuit and the MOSFETs are still on the board and they are not, there's no pull down resistor or there's no drive transistor that has a pull down ability to the gate, then you end up with voltage like on the gates of the FETs, just like due to being in circuit, and that causes the FETs to like be on and pass DC to the terminal. So I think that's probably what's happening here. So I think what we need to do is just bridge over the gate to source of each of these output MOSFETs, and that will help us to learn a bit more about the faults that we've got. So let's do that real quick. We need to do that 8 times. We've got 8 output FETs. The other option, of course, is to remove the output FETs entirely. I don't know what would be quicker, to be honest, running quick jumpers or removing them entirely. Running jumpers will be quicker in the long run, I think, because they're quicker to remove, whereas reinstalling the FETs just takes a little bit longer. So I think if we just grab some quick jumper bars here with the tweezers, which are, where's my tweezers at, yo? Here they are. So in order to jump over the output FETs, all we're going to do is grab a little bit of spare wire, a little bit of metal here, bend it round into a U shape and connect it between the gate and source of the MOSFETs, and that will prevent them from spontaneously turning on when we try and power up the amplifier. I might actually not need to do it on every single MOSFET because they might have the gates in parallel. Let's have a look. Yeah, I don't need to do it on every single one, just one per bank, and that will prevent the bank from turning on, so that's good to know. So we just need 4 jumpers, 1, 2, and then 2 on the other side as well. Okay, cool. So we should now have a jumper for each bank of output FETs, so they shouldn't spontaneously turn on anymore. Just installing those jumpers, fingers crossed, provided I've got that correct, should now allow us to power this board up and it shouldn't draw excessive current anymore. Let's have a look. There we go. Yeah, awesome. So now I can power the board up, no excessive current draw, and we don't have any DC on the speaker terminals anymore. Okay, that's good. So the issue is clearly being sent through the drive circuit, either from the drive circuit itself or through the preamp circuit. So now the most interesting thing that I want to understand is whether we still have any DC on our potentiometer here for, I think it was the treble one at the top. See if we've got any DC on here, which shouldn't be. This should only be signal path. There should be no DC on this whatsoever. Ah, we do still have DC. Okay. So it looks to me like we might have a fault with the preamp. Okay. So, this is our preamp here, preamp board. Now, I did actually do some work to the preamp board the other day. And I thought I had rectified it, but clearly not. So let's have a look and see whether we've got another 100 DSM. I just want to have a look and see if we've got another DSM amplifier from Rockford that I can take for reference. We might not have, but this actually will give you a good chance to see how many Rockford amplifiers this guy sent in for repair. It's absolutely crazy. Let's have a look. One sec, let's just get this one away in here. What's this one? Is this the 200 SI? Yeah, let's whack that in there for a minute. Because this customer sent in so many Rockford amps. Some of you will see all the ones I've got in here. Right. Right in there. Get that in there. Okay, 200 XI. So we have. Maybe I get another camera view. Different camera view for this, so you can see all the boxes. Okay, different camera view. Let's bang this camera on here like that, maybe. Okay. So we have a 200IX. We have a 100X2. So I'm looking for a DSM. We have a 60IX. We have a 250M2, a 250X2, 250M2, 500M, another 500M, and a 200X2. So none of those are the DSMs that we want for reference. Put those back in their box. They came in. how was this even? 1, that, 2, that, 3, 4, 5. Almost probably like that. There we go. And in the other box we have a 60IX, a 100X2, a 200IX, a bunch of EPX processors, and I think that's about it. We've got this one over here, which is a something similar, but not what we need. So we don't have another DSM model to work with here, unfortunately. So I can't take a reference from a good amplifier, known working amplifier. Damn. Bugger. Okay, so preamplifier then. Alright, let's have a look. So this is our preamplifier. We have a little daughter board here for the preamp. I think maybe what I should do is have a probe around, see what's going on in here. We've got a couple of LM833s on here. This is our little preamp card for this amplifier. So we've got a couple of LM833s. These are going to be the op amps. Okay. Then we've got some resistors. Now this was all water damaged, believe it or not. So I've done some work on this preamp card already in the past, just like last week. We had water damage and corrosion to these three components here. This was a capacitor and 2 resistors. On this side was good, these ones were water damaged. Now in order to get the correct value capacitor, these are very old surface mount capacitors, so modern surface mount caps are much greater, much higher in value than these older ones are for their relative size. And I was struggling to find a capacitor that was the correct value to go here, so I used 2 smaller ones in parallel, so the value's fine. Now other part of these traces were kind of bad, so you can see that they're exposing their copper after cleanup. I removed the LM833s at one point. Now the one thing that I'm wondering whether I put the LM833s on back in the correct way around. I think I did, because I'm usually good at that, but they are in opposite orientations to each other, and this board doesn't have orientation markings on it. So I just wanted to double check that I put them in the right way. Now one way that I can check is I can obviously look at the VCC voltage supply for these op amps and make sure that they're going to the same places. So let's just have a quick look at that. Let's pop that there. There we go. So in the 833 we have VCC supply going into pins 4 and 8. So if we go for pin 4 here of this 833, let's see, 1, 2, 3, 4. Okay, yes, so they are actually in the correct orientation. They are meant to be opposite to each other because we have pin 4 continuity there and pin 8 continuity there and there. So the orientation is correct. I did put them back in correctly. Excellent stuff. So the only reason really that I can think we'd get DC through this board is if the 833s are damaged internally possibly, or there's like a trace leaking to another trace. So I'm just going to take my soldering iron and just see if I can clean up, just sort of run through, reflow a couple of these solder connections here, just to see whether that makes any difference. Trace there. I'm just having a quick check of some of these traces here. That's supposed to go through to that side. It probably isn't supposed to touch any of those. That to there, that to there. That goes down to that capacitor. Okay, a little bit of flux then on my card here. With a little bit of flux, we will make it through the night. With a little bit of flux, we don't pass by. Problem is, the original pads on this driver card specifically have all been damaged a little bit by the moisture, by the water corrosion. There was a bunch of water damage on this one, so I'm just wondering whether the vias are bad on this anyway. But you can't get replacement preamp cards for this, so going to be a little bit screwed if it's the actual traces on the card itself that's bad. Right, let's just power it up again. So let's get our beat of cardboard here. Yes, please. Okay. So what I'm going to be looking for now is, it's going to be quite hard for you to see because I'm going to be probing on this card here. I'm looking for DC leaking on these op amps because they could be bad. So there should just be signal basically passing through about all of these components here. So if I power it up, hopefully without getting an electric shock. Okay, so not seeing any DC so far, here or here, here or here. And how about on this side? Looks okay. This side looks okay. This side looks okay. Alright, so I haven't got any DC there. So let's go back to our potentiometer real quick. I wonder if that's sorted. I wonder if it was just a bad connection on the preamp card. So let's go back to here. Okay, so no, still looks like we have negative 14 volts on there. I honestly don't believe that should be there. This should just be signal getting passed through here. So let's follow the DC that shouldn't be there along and see what trace that goes to. So we've got negative 14. Let's see if adjusting the potentiometer changes them at all. Yeah, adjusting the potentiometer does change the DC a little bit here. Changes it a lot actually. Okay. So it's coming in through either this pin or this pin from the preamp card. So that one or that one. Okay, so let's flip that back over and have a look on the front. So that's basically a bunch of these capacitors here. Let's have a look. See whether we've got the DC on the back of here on any of these caps. I feel like these should be DC blocking caps here, or like high pass filter caps. Okay, let's have a look at the LM833s. Let's see if we have any DC on any pins of these other than their supply pins. So pin 1, we have nothing on this one. I'm just checking this 833 now. Pin 2, no DC there. Pin 3, no DC there. Okay, pin 4 is VCC. Pin 5, no DC there. Pin 6, no DC. Pin 7, aha, pin 7, we have some DC. Negative DC. Okay, that routes round to this capacitor here. Okay, and does it go anywhere else? Yep, it also goes round to this trace here, which goes in. That jumps to the back of the board, goes down to the bottom to the pin out of the bottom, out of the card. Okay. How about on this other op amp? This is going to be the other channel. So that was pin 7 that had some DC on it. Okay, no DC on pin... Oh no, pin 7's up here on this one. Okay, yeah, we have DC on pin 7 of this op amp as well. So I wonder whether one of the op amps is bad, or there's a trace touching somewhere that it shouldn't be. Now obviously we need to be getting plus minus 15 volts into this preamp card, because we obviously need it for the op amp. So let's see where else we get it. So we shouldn't have it on any of these pins, because these are going to the potentiometer for the treble adjustment. So let's just double check where we get plus minus 15 volts elsewhere. So not there, not there, not there, not there, nope, 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 nope. That's going to be the inputs. Okay, that's negative 15. And that's positive 14. Okay, so it's right over the end, right over this side. So these two pins are our VCC supply input to the preamp card. So I just want to make sure that none of those pins are shorted or have a low resistance to the pins that are supposed to have audio on it. So let's go for this one here. Yeah, not really getting any low resistances there. Let's try the other one. Okay, not getting any low resistances there. So we're not getting DC as a result of a low resistance short or leak from the supply voltage input through the op amp. So I don't necessarily think it's the op amp that is at fault here. I think it might just be that one of the inputs to the op amp is not actually connected to anything due to a bad soldered joint on one of the components of the preamp card here. So we're going to use the same method that we used earlier with the other drive cards to remove the preamp card entirely from this board and have a really good look with the microscope to see if we can see what's up with the solder joints or something on there, because it was subjected to some moisture damage. So Cirrus says, if the inputs have DC, then an input cap has shorted. Yep. The inputs don't seem to have DC, so I think that the only reason we have DC on pin 7, which is the output of the op amp, I think that's because one of the inputs are like floating. So we're just kind of getting phantom kind of charge on it, like in the same way that you would get a MOSFET phantomly turning on when the gates are floating. And I think that might just be because of like some poor solder connection on this preamp card or something like that. Because this preamp card, like I say, was subjected to some moisture damage, some corrosion, some condensation damage, something like that. Oh, this board is almost too hot to touch now because of the soldering iron here. There we go. Heck, looks like one of these got ever so slightly... shit. Okay, need to make a small repair to one of the traces on there. Unfortunately, this delicate stuff that has come off. No worries. Can do, no problem. Okay, so with the preamp card removed, let's just see whether our DC is removed and disappeared from this potentiometer, which obviously it should be. Yeah, clearly. Yeah, great. Right, let's turn our attention then to our preamp card. Now we can actually inject our own supply voltage to the preamp card if we wanted to kind of diagnose it out of the amplifier here and see why the voltages are leaking where they shouldn't be. Let's take our microscope and have a look through the scope at all of the traces and stuff, because I suspect we've got some nonsense going on here. Okay, what are we saying then? Alright, so this is the area that looks kind of janky, because this is the area that had some pretty bad moisture, water damage, corrosion, etc. So I'm just going to take my multimeter here and just make sure that all of these connections are making a good, actually making a connection here to these parts. So let's get the lights out of the way for a sec. So this 302 resistor, we need to make sure that we have a connection to the resistor up here. Yep. And same for this one here. Yep. Yep. Okay, that looks alright. This 102 over here. That doesn't really seem that great, that one. Where's my isopropyl? This one doesn't seem great. (102). And that's this trace here. Okay, after scratching away at it, it seems okay in the end. Let's try the other side. So that's connected to that capacitor. Yep, that seems alright. So the op amps, they all connected, all those pins. Yep. Doesn't look great, but that is soldered, because otherwise that would be moving around. And this one, yep, these are all soldered. Okay. Let's have a look at these resistors down here. Yeah, that's definitely, everything seems connected and good. So the only thing left then really must be that the op amps are a little bit, you know, they're leaking possibly. But it's strange because yeah, we've got it's pin 7 on both of the op amps that has DC on it. And from my experience, that means that the op amp isn't getting, has one of its inputs floating or something along those lines. What's this one supposed to be connected to? I don't see a trace for this one. This is input 2, but it would be these ones over here, wouldn't it? 5, 6 and 7 it would be. 1503. That one looks good. A couple of capacitors over here. Nice double cap job. Yeah, you know how it is. Couldn't find the correct value, so managed to parallel one. Like I said, Sam, if there's no DC on the inputs and the output has DC, then the op amp has popped. Weird. Okay, cool. Let's remove the 833s and replace them with something else. Let's see if the DC goes away. Right, a bit of flux in here. What I might do actually is I might even just connect up a bipolar supply to this so we can look at it off the bench. What do you reckon? Before you do, short the input pins together to prove it's dead. That's a shout. That is a great idea. Alright. Shall I do that before we remove it? And then use a power supply to inject some plus minus, some bipolar rails. Alright, guess we're doing that then. Okay, so we have to have a think about which one's which. So we want to short out the input pins in which case it's 5 and 6, because pin 7 was the ones that had the DC on it, wasn't it? So if I go ahead and short out 5 and 6 on both of these op amps, bit of a big blob on this one. Alright, there's 5 and 6 on that one. Do be shorted. And over here, 1, 2, 3, 4, 5, 6 over this side. There we go. So now we just need to shove some supply rails in. And that was all the way over this side, I believe. I have to have just a double think about this. Let's grab the multimeter and just double check. So supply is pin 8 and 4. So if I go off pin 8, okay, it's over this side. Okay, cool. And 4. Cirrus, remind me, is pin 4 or pin 8 the positive supply or the negative supply? Which is which? I can't remember off the top of my head. LM833, same as a 072C and whatnot. So I'm not shorting 2 and 3. Reason being is we didn't have any DC on pin 1. 4 is negative, 8 is positive. Thank you very much, guys. Appreciate you, as always. Right, let's find some spare piece of wire and hook up to the bench supply here. Positive and negative. We also need a ground as well. We're going to need a ground as well. Let's shove that in there. Yep. And shove that one in there. And now I just need a small piece of wire for ground. That'll do. Okay, so this is our ground. Now, which one is ground on this preamp card? And just need to get the amplifier back out here. Just have a quick look and see which one's going to be ground. So the speaker terminal negative is ground for the output side, so that should be match up with a ground on the preamp side. Hopefully, he says, maybe. Huh, maybe the preamp is referenced to the ground on the RCA ring. Ah, here we go. Yeah. Okay, it is this middle one, whatever the heck that is. It's like a pin 27 in from the edge. Let's have a look. So we're that way around, going in. We are. This one right here with the 2 lines going into it. Okay, fantastic stuff. That one's our ground right there. That one. There we go, there's a ground as well. So let's tin a ground wire. Yeah. I appreciate you can't really see much right this second, but everything's a bit hectic right now, so just bear with me. So there's our ground wire tinned, and here's our bipolars. Probably tin those as well. This one looks a bit hectic, like a mad scientist's hairdo. See if we can get that tinned. My man! Okay, we are tinned! Tinned! Excellent stuff. So, we want our ground wire on the middle one here. Now I have to be careful because these wires are going to want to pull this card, this tiny card, off of the bench if I'm not careful. So let's shove our ground on that one. Yes, please. See what I mean? And our now, sorry. Let's have a look. What did you say? 4 was negative, 8 was positive. So our negative is 8 was positive. 8 was positive. So negative is going to be this one. Yep. Three. Get up on the bench. Thank you very much. And our positive is going to be this one. Okay, I think I've just about managed to get those connected. So I'm going to put the microscope to one side for a minute. So I think we're done with that for a sec. Right, here we go. Now we're just looking at the board. Right, so we have our power connected. Make sure there's no little strands of wire that are bridging those two together. Looks like there might be a little bit close for comfort. And ground. Alright, excellent. So let's get this powered up then and see whether after shorting 5 and 6 together on both of these op amps, we still get DC. So I'm going to give plus minus 12 volts. Okay, so let's have a look and probe pin 7 of this one and see what we get on the scope screen up here. Okay, well, yeah, we do actually still get DC. So I guess, Cirrus, yeah, you were, by the looks of it, accurate, because even after short, we get DC on pin 1 as well down here. and pin 1 over there as well. Okay, I'm just going to, one last thing, I'm just going to short out pins 2 and 3 as well on both of these, and that will just absolutely rule out. That will just absolutely rule out any other possibility that anything else is wrong other than that these are toast. Oh heck. Ah, that was 3 and 4, damn it. No! It shifted over just to the wrong side at the last minute there. A bit of flux, and I'll use the iron to try and drag it over. Alright, so I've removed the short. Let's try again. Let's try and get that in the middle there. There we go. Excellent. Right. So yeah, we're all shorted up. So if we still have DC, we know that they are forked. Forked. Yep, still got DC on 7. And still on 1 as well. Alright, let's get these op amps out of here then. So we can replace these with a whole host of op amps. They're just for the preamp. Can use 072Cs. I'm going to use some 4052s. I think I've got some of those spare. Wow, this one is taking its time to desolder. What's going on? There we go. Okay, let's remove my bridges that we just made. There we go. Okay, let's drop a little bit of fresh solder on these pads. These pads have definitely seen better days just from the condensation corrosion that they were subjected to, which is why this amplifier is here in the first place, I imagine. Okay, yep. That one doesn't want to take solder too well. Let's give it a little scratch. It's a bit better. Yep, that's better. Okay, looking good on that one, and this one over here wasn't so bad. The moisture wasn't really over this side as much. There we go, looking alright. So just for confirmation then, if I turn it on, the supply's on now that we have the op amps removed. Shouldn't get any DC on the pads for pin 7 anymore. Nope. Oh, I'm such an idiot. I'm an idiot. I just realised I was not turning both of the supplies on. I was only turning the plus 17 volt output on. I wasn't flicking both switches. So actually those tests that I just performed mean nothing. Okay, but anyway, maybe we'll replace the op amps anyway, seeing as we're here. But yeah, let's just double check that we don't have DC on pin 7 anymore. Got 12 volts on there, 12 volts on there. Just make sure there's no DC floating around anywhere else. No, looks fine. Negative 12 on that one. Positive on that one. Okay. So yeah, we're good to go. A couple of fresh op amps and we should be good. Alright, want a bunch of flux on this because I'm going to be doing it with the iron because I don't really want to risk overheating these new op amps. They're quite delicate to temperature, believe it or not, these ones. So just going to dump a bunch of flux on the board, load up a little bit of solder on my tip and just touch it on the legs of these op amps. That way we can know for sure that if there's any further problems, we know that it's not because the op amps got damaged during soldering. Just want to remove all potential culprits if there are further problems. So this just removes one potential culprit by doing it like this. Okay, that's that one should be done, and let's do this other one. This one's upside down compared to the other one. Did you get a new test mic? Test mic? As in Dayton DATs? So I've never had a Dayton DATs test mic. I've just had the the DATs V2, V3 with the impedance analyzer. Yeah, I fixed my V2, and someone also lent me a V3, and they very kindly said, "Oh hey, keep the V3, send me back the V2." So I'm eternally grateful for that very kind gesture. So I'm able to keep the V3, and the V2 will be going back to the other guy who lent me the V3 originally. So that's very kind. So okay, I've just soldered on the op amps. I'm just going to make sure, because these pads are quite tricky to solder to at the moment. Whoa, hello, the big bear vids. These pads are tricky to solder to due to them being very old and having had moisture damage in the past. I'm going to go ahead and have a look through the microscope to check that they are soldered properly. Make sure they don't wiggle when I push them. Alright, a little bit of isopropyl alcohol just so it'll make it easier to see. There we go. Actually a little bit of a solder blob there. It's not touching anything else though, so that's okay. Now that one doesn't look soldered to me. That one looks a little bit wobbly, so I'm going to have another go on that one. That's better. That's not moving as much as it seems to be before. Let's check this side. Yeah, seems alright. Seems alright. Seems alright. Seems alright. Okay, cool. Let's go for this top one. This one should be all fine. That's looking perfect. That's good, that's good. Okay, cool. Yeah, I think we're good in the hood. Let's clean these up. Yep, looks nice. Excellent stuff. So, we're going to power it up on the bipolar supply, bench power supply, to make sure that there's no DC on the op amp still. If there is, it means that one of the inputs probably doesn't actually have a connection to where it's supposed to be connected to, which will be a nightmare because it all looks like it does. Okay, cool, cool. So let's go for pin 7 over here. Let's turn both supplies on. Okay, no DC pin 7, pin 1. Pin 1 we got -7. Okay. -8 on pin 4 should have a supply on it, and we actually have -9. It's not. Hang on a minute. -12 looks like we're actually drawing some current through this 100 ohm resistor. Damn. Okay, why is that? Something is shorted? Actually, no, never mind. Ignore. Wait a minute. Oh no. We got DC all over this one. This is a brand new op amp. This is a brand new op amp. We got DC everywhere on it. We got our supplies on pin 4, 9 volts, and pin 8, 9 volts. Why is that? Well, neither of them are heating up, so they're not like getting hot or anything like that. Negative, right, so this one, on this op amp, pin 1 we have -7, pin 2 we have nothing, pin 3 we have like -1, so that's probably why we've got -7, -2.6, I wonder whether it's just like the fact that it's wet with isopropyl alcohol. If I dry it off properly, I wonder whether it will go away. Let's get the hot air gun and sort of dry it off a bit. check the poly fuses if there are poly fuses. I don't think there's any poly fuses. I'm just waiting for the isopropyl to dry, just in case there's any voltages leaking around the board as a result of there being like conductive liquid on the board. Isopropyl isn't conductive, but when mixed with other stuff and crap, like what might be on this board, it could be conductive a little bit. It's also possible, because this board isn't actually mounted into the PCB, the inputs and outputs of the op amps might be floating at the moment. So that's why another reason we might be getting some DC. So it might be a good idea to test this with it mounted in the main board as well. Yeah, my voltages appear fine. I've got the correct voltages after the 100 ohm sort of resistive resistors. Right, that's cooled down. That's dried off a little bit here. So let's go back to having a look. Pin 1 here then. Yeah, still got -7 instantly. Bro. If I probe the pins that would otherwise go to the potentiometer, actually, yeah, you know what? I wonder whether it's just because it's not in the main board. Okay, I think really the only parts on this board that would cause DC to leak is going to be the op amps, and we've just replaced them for brand new ones. So I'm gonna just go with my gut here and think that maybe we've got a bit of leaking DC because it's not in the main board, so the inputs to the op amps aren't actually connected to anything, so they could be like floating, phantomly turning on, or like causing some leakage on the outputs. I could do the same thing that we did with the other op amps. I could short out pins 2 and 3 and 5 and 6 just to confirm that the op amps are behaving as intended. But yeah, what do you reckon? I'm just gonna, no, you know what? I'm just gonna shove it in the main board. Screw it. Shove it back in the main board. See what it does. If it's still screwing up, then I'm just gonna leave it for now. Call it a day. So here's the main board. Get that in there. Wiggle, wiggle. Tweezers, where are they? I'm sure I'll grab some other random tweezers here. Okay. Fucking hell, I had it. Alright, yeah, fresh op amps, moment of truth then. I don't really have very high hopes, to be honest. Like, I'm still seeing that DC there. But, let's just see, there's not really much else on that preamp board that would really, like, you could change. That would resolve the issue. There's two op amps and there's just a bunch of resistors, capacitors and stuff. I can't really... The DC isn't on any of the capacitors, so it's not like they're leaking. And you wouldn't have on a signal bearing capacitor, you wouldn't have DC on one side that could be leaking through as a result of a bad cap. So the only reason that there'd be DC leaking through to the signal path is as a result of bad op amps. So we replace both of those, so it should be fine. Right, let's see. Power supply on, power up. Fuck's sake. But this time we have positive 10 volts. Why? What are you doing, bruv? Why? Positive 10 on both of these. I don't get it. I do not understand, mate. Anything on... Oh, nice. And now we also have negative 15 volts on the base adjustment. Like, what? Man, what the fuck? Two brand new op amps. That's all we did. Why have we now got it? Oh man, you know what? Got a feeling this one's gonna be. I've got a feeling this one's gonna be like. This one's gonna be like, nope, fuck that. Because this preamp card had water damage on it, I feel like we might just need a new one of those preamp cards, which aren't going to be available anywhere. So. Why has it changed? Why do we now have DC on this one as well? Do not understand, bruv. Oh wait, I know why we've got DC on that one. It's because there's a small solder bridge there, bruv. That's why there's DC on that one. Let me just correct that real quick. Figured that one out real quick, didn't I? There's a tiny solder bridge on this pin here, that's why. So let's just quickly correct that. But that still won't probably change why we've got DC on the other one. Alright, that's my bad. That's my bad. Alright, okay. Tiny solder bridge between the VCC pins and the base one. I suspect that probably won't clear this up. No, I still got 10 volts on the treble one. That wasn't anything to do with that. The base one's now clean. But yeah, the treble one's still got a DC there. Ah, fucking hell, man. Well, one last thing that I want to do is, just before we go, is I'm going to put the driver cards back in. I'm going to swap their orientations. I'm going to swap their locations around. The reason for that is because we had at the start when we were looking at this amplifier, one channel was allowing me to bias it correctly, the other channel wasn't allowing me to bias it correctly. So I just want to see whether that's as a result of the an additional fault on the drive circuitry. So this one was on the bottom there, so that's going to be now become the top one. So, which is going to be the bottom one after we flip it around. Now, which way round the fuck did this go? Holy shit, I don't know. It doesn't actually tell you. Oh no, that's a disaster. There's no markings or any indication as to which way round that's supposed to go. Well, alright then. I guess I'll have to look back through the stream and figure out which way round it was supposed to be. That's a pain in the arse, isn't it? What? It's not like there's any pin markings either. Wow. That's stupid. Okay. Okay. Eesh. There is a bit of a difference. There is something that tells you, okay? The thing that tells you is that these boards have a slightly longer edge on this side compared to that side. See, like these pins aren't directly in the middle. There's a slightly longer edge that side to that side. So what I need to do is look back through the stream and see whether there was exposed white on the board there or whether there was exposed white on the board there. I've got a feeling it's this way round only because of where the flux goes to. See, the flux goes right to the edge here on this one, so I think it's probably going to be that way round. But for this side, I don't know if that's going to be the same or like flipped opposite. Oh man, what a nightmare amp. Bobbert said, I fixed that HD 1200 I emailed you about. Reverse engineered a lot of the PCB. I'll be making a write-up for it, including how to change the switching voltage to 12 volt for low power diagnosis. Man, Bobbert, nice job, man. That's fucking awesome. You should be proud of yourself for that. Op amp side of the board faces you, says James. Cool. Thank you very much. There's no op amps on... Oh, there is. There's this W3. Oh, there's a W3 on both sides, so that doesn't help. I don't even know if that's an op amp anyway. Thanks anyway, James, for checking. But yeah, this is the output driver card. I can look back through the stream and check it. James H says open feedback resistor. That would only affect one op amp. Maybe. So the next thing that I guess I'll have to do with the preamp card is to go through and just check the resistance of every single resistor on there, just to see whether any of them are open. We could do that now real quick actually, couldn't we? Let's have a go through these resistors while we're here. Let's have a look. Okay, so my resistor, my multimeter camera has screwed up again as always, so let me just quickly reset that. Okay, back in business on the multimeter cam. Right, let's go through each and every resistor on the preamp board and see if any of them are out of whack. So, 302 is going to be a 3K. So 3K. Oh man, what is with my multimeter camera? Yo! Just work for once, will you, bruv? Now we've got a nice synth wave effect on the main camera. Love to see it. We're just going to have to leave that there. I can't be bothered to fix that right now, but hopefully you enjoy the pink and green. So, 3K, yep. 3K, yep. 203, 20K, I think. No, 200K, 200K. 200K. Oh, no, it is 20K. Yeah, wait, yeah, sorry, 20K, yeah, 20K. And this one here, 20K, pretty much. 102 is going to be a 1K, yep, there we go. What else do we have around here? A couple of resistors down the bottom here. 1622. Yep, that's correct. Another 1622. Yep. A 102. There's some of these resistors I don't think I'm going to be able to get to. Yep. 271. 270. Yep. 202. Don't know if I can get to that one. Yep, that's correct. Alright, got to all of those bad boys. 202 again over this side. Yep. 271. Yep. 9090 or something weird like that. What's that? Well, that's low resistance, it's probably fine. 1503. Yep. 1503. Yep. 1503. Yep, and a 1990. Yep. Okay, so every single resistor on this preamp board checks out okay. The only other thing I can think might be bad is if there is a resistor on the main board that feeds the preamp with feedback that is open, that is bad, that could be causing the DC. Right, I guess, maybe, I don't know. So we can go through every other resistor on the board here. What do we got? I've got a 100 ohm here. Yep. Got another, got a 10 ohm there. Yep. I got a, what's that? 821. Yep. 392. Yep. 302. Yep. A 10 ohm. Yep. 10 ohm. Yep. A 10 ohm. Yep, these are all gate resistors anyway. Something 22. What's that? 220, 220. That's coming up as a 1K. A 122. Yep, that's correct. 132. That's correct. 333. That's correct. 10 ohm, correct. Yeah, bro. Maybe some around about here. Right about 333. Yep, correct. 471. Yep, correct. 571. Correct. 333. Yep, 333. 28.6, close enough. 751. Yep. Yeah, this is all fine. All seems fine. Hien, yo, what's up, buddy? It would pass DC rather than block it. Could be a shorted signal cap if it's a surface mount one. But the thing is, there wouldn't be on the preamp card any capacitors that have DC on one side and signal on the other. Like, that's not a thing. Not as far as I'm aware. Yeah. So that doesn't make any sense to me. Sirius says, long to the left on the top one, long to the right on the bottom one. Top being the 4 big black caps. Alright, let's have a look. Sirius, thanks so much for checking that, buddy. Really appreciate you there. So, you say... so this is... okay, let's just flip this back around. So, alright, there's the bottom. So I'm going to flip those. So that was how it was before. And that's how I want... oh, fuck. Oh, shit. I've lost track of which fucking card was in which location now. Fuck. Up. So you said that on the long to the left on the top one, yep, that's that way. Long to the right on the bottom one. Yeah, that's kind of how I had guessed it should be as well. It's hard to tell. You didn't hold stuff still for long enough. Yeah, I get you, bro. I get you, bro. That's kind of what I would have said though as well. But super annoying. I don't have a reference. I could reference it to a ground pin, yeah, I could. Just seeing whether the DC goes away if I fiddle with these potentiometers at all. I'm just kind of wondering if the potentiometer is bad, right? Then let's say that the potentiometer... hang on a minute. If the potentiometer is bad and therefore not creating a connection for the preamp, could that cause there to be DC because then one of the inputs to the op amps is floating? Do you know what I mean? I wonder whether we do the same short circuiting of the potentiometers that we did on the other board that we didn't have the potentiometers for. And just to rule out the potentiometers being like open inside or bad or something like that, Or because I suppose I could just check the resistance of them, couldn't I? So in order for them to be at minimum position, we needed to have a short across. Ah, shit! You know what? You know what? It might even be bad potentiometers after all, because no matter which position I have these in, we don't get the short circuit between. Bro, I wonder whether it's the potentiometers being bad. I did say, seriously, I did see you mention a dodgy potentiometer before. I did see you mention that previously, but I wouldn't have like thought that a potentiometer being bad like this would cause DC to become present in the circuit, because I was thinking, okay, well, the potentiometer is just passing audio, so if it was bad, then it just means that a sine wave wouldn't make its way through the potentiometer. But if the potentiometer is loading the op amps inputs, then being open and floating inside the potentiometer might cause there to be some kind of phantom DC up here on the op amp. Yeah, So under normal operation, there shouldn't be any DC on the potentiometers at all. So the potentiometers aren't like controlling a DC signal, they are actually passing the audio signal through them. But I'm wondering whether one of them being open like that. Because hey, this is the same problem we had on that other amplifier that we were working on, that didn't have the potentiometers fitted. I was getting DC on pin 7 of the op amps with the potentiometers like not present, and that DC only went away when we fitted potentiometers, like, well, fake potentiometers, when we bypassed them correctly. Oh fuck. So all this time it might have just been bad potentiometers, and Cirrus might have been on the money from the start, and I didn't even really consider that. Cirrus might have caught it from the get-go, you know. Fuck. See, this is one of these old Rockford isms. This is a Rockford ism, right? No other freaking amplifier on the market would cause DC to be present on the signal path if you removed the potentiometer, or if the potentiometer was bad in such a way that it was not making a connection inside anymore. That would not happen. I've never seen that happen before in any Korean, Brazilian, Chinese amplifier, and that's what I know. That's what I've learnt on. So with this Rockford thing, man, yo, I hope you're liking the synthwave vibes, by the way. Not intentional. I didn't put a filter. It's just my HDMI screwing up. So, fuck. What I'm thinking is, just as a last thing for today, let's remove these potentiometers and let's just open them up. Let's have a look inside. Let's have a cheeky peek inside if we can, because you can open up these potentiometers and have a look at the wiper and stuff. Have a look at the condition internally. Man, I need to find my freaking silicon tip for this sucker, because it is not doing as good of a job without it. I'll tell you that much. You know what, rather than, fuck it, oh man, what do? If I had some resistors like right here, I would just bypass those potentiometers just to see if that fixes it, but I don't have any more mega ohm resistors. Fix the HDMI, there we go, HDMI fixed. Well, yeah, pull pin 2 and 5. Guys, what I'm going to do is, just as a last little thing for tonight, I'm going to spray some isopropyl into the potentiometers and swish it around, because I'm kind of like at the end of the stream now, but just as a last thing, I'm going to spray some isopropyl alcohol into the potentiometers and swish it around a bit. Where are we? Here we are. Just to see whether that changes the behavior of what's going on, okay? Because if that changes the behavior of what's going on, then we know the potentiometers are the issue. And yeah, to be fair, given the amount of condensation and corrosion that was actually on this preamp circuit, I reckon that these potentiometers are absolutely screwed internally. I think they're fucked inside, man. I think that's what it is. So with these potentiometers, I don't want them to be at 50%. If I'm going to bypass them, I want them to be at like minimum position, because these potentiometers go from 0 dB to, I think it's a plus 18 dB boost on bass and treble. So if I want to bypass them, I want them to be at minimum position, which is what I did with the other amplifier that we don't have the potentiometers for earlier. Alright, so I've fiddled with that. Let's see whether that just changes the resistance on the potentiometer, you know, the DC here. Ah, you know what, it kind of does, you know. Oh, it does. We got 7 volts on this one here. Sorry, we got 7 volts and it's steady. It's not really changing. I'm going ham with this potentiometer, trying to get it to like make a connection somewhere, because that 7 volts needs to disappear. But the 10 volts, which is now on this one, this is really odd. It definitely is kind of changing its behavior a little bit. 6, 6. Yeah, even though I'm not kind of getting the results that I wanted here from this quick test, I think it might actually be the potentiometers that are bad here. So what I'm going to do is, I'm going to end the stream here, guys, but what I'm going to do is I'm going to go looking for some more mega ohm resistors and 5.1k resistors, so that we can effectively bypass these potentiometers entirely, just to rule them out of being a problem here with the circuit. Then, with the potentiometers bypass, if the DC disappears, great. We can move on to the drive circuit faults that this amplifier probably seems to have. If the DC doesn't disappear with the bypass, then I'm just going to have to try and figure out whatever the hell is wrong with the preamp card, but I can't really see what else could be wrong with it. It's just got 2 op amps on it, a bunch of resistors and capacitors. The capacitors wouldn't be the problem, like I say, because they wouldn't have DC on one side and signal on the other. The resistors all read perfectly okay, and the op amps are brand new, so the track in the pot is probably fine, so just short the wiper pin. I don't know how these potentiometers work, so I'm not sure. The track is probably fine, so just short the wiper pin. Oh, I see what you're saying. Short the wiper pins to wherever they need to go to. Yeah, I see what you're saying actually there, Cirrus. In that case, the shorts that I need to make are between these pins here and these pins here, and then these pins here, and these pins here. So if the track is okay, then that should do the job. So that's the wiper to the end of track shorted there. Alright, let's just see what that does. If this makes the DC disappear, I'm gonna literally lose my shit. Nope, we still have DC, we still have 10 volts, 10 volts. Yeah, sadly that didn't do anything. I wish I had another one of these amps. Like this guy sent in a bunch of Rockford amps, and like on a lot of them there was like a duplicate, one that worked, one that didn't, or one that was like different fault to the other. But this is the only DSM that I've got, so I haven't got a reference of a good one. Yeah, no, there's just DC fucking everywhere, bro. What is kind of interesting to me though is what happens if I short the DC to ground? Like, does that 10 volts DC have any actual guts behind it? Does it have any actual fucking current behind it? Yeah, it seems to. By shorting that DC, the current draw goes up to 1.2 amps, I think. Got 1 amp current draw. If I short that out, yeah, we do actually add some current draw if we short that out. So it does seem to have some current behind it. Really weird, bro. Yeah, we had about... I did, yeah, I powered it up slowly. I was just kind of pulsing it. Let's just take the thermal imaging camera, just have a quick look at the preamps board here. Op amp temperatures are 50. Seems a bit high to me. 60. Yeah, I don't know about you, but those op amps seem a bit stressed. 60 degrees on the op amps, they seem a bit stressed. So they're either dead, or like they're sinking a bunch of current because we shorted out the potentiometers. I don't know. I'll look at this again another day. I'm done now. I'm done now. Well, for today. For today, I am done, bruv. So guys, hope you enjoyed. Boom or bust. I guess I might be filming a boom or bust tomorrow. I haven't printed any new enclosures for boom or bust for tomorrow. I might set one going tonight, or I might just do the sealed chamber tomorrow, the sealed box test tomorrow, so that you guys can see how a sealed box performs, which I think a lot of people are interested to see. But yeah, I'll catch you guys in the next one. Have a great rest of the day, and yeah, take it easy.